Today we will solve the problem 3.32 of Griffith third edition, Introduction to Quantum Mechanics. The problem 3.32 is an anti-Hermitian or skew-Hermitian operator is equal to minus of its Hermitian conjugate. That is, q dagger is equal to minus q. So that the expectation value of anti-Hermitian operator is imaginary, and so that the eigenvalues of anti-Hermitian operator are imaginaries. So this problem contains 5 parts. First we will solve A and B. So from A we can see this is A, answer for A. They asked to find so that the expectation value of anti-Hermitian operator is imaginary. So the expectation value of q dagger is uh, by definition it is psi q dagger psi. So now you bring psi dagger to the vector. So I have brought into vector. So we know that q dagger is minus q, not q dagger is not q, because that is for Hermitian operator, it is minus q. So I have taken that multiplication factor minus 1 outside. So this will be minus q psi get psi. So which can be written as minus psi q I am bringing to the get vector, and I am taking entire things complex conjugate. So which is exactly equivalent to this one. Uh, so what is this? This is nothing but expectation value of q, but you have complex q complex. So there is a negative sign. Q dagger is minus q complex conjugate. So naturally it will be imaginary. Then we will come to part B, section B. Let the operator, anti-Hermitian operator, act on the psi, get vector psi. You will get eigenvalue lambda multiplied by that get vector psi. Now let this operator q act on get vector, then you will get lambda psi. So this can be taken out. Lambda is a number, so you can take out then inner product of psi with psi. So now instead of taking this q to the get vector, you bring to the bra vector. So bra vector a dagger, sorry, q dagger in this case, which is minus q. So this will become, when q act on psi, you will get lambda psi. There is a negative sign. Remember that there is a negative sign. Then if you bring this lambda outside, remember that lambda is in bra vector side. So naturally it will be lambda star, that is a complex conjugate, minus lambda star. So lambda star is equal to minus lambda. From compare this and this, minus lambda star is equal to lambda, or lambda star is equal to minus lambda. Naturally the eigenvalue is imaginary. Then we will move for CTE part. Then section C is so that the eigenvectors of an anti-Hermitian operator belongs to two distinct eigenvalues are orthogonal. We have to prove it. Let q act on psi, get vector psi. You are getting an eigenvalue lambda multiplied by this get vector. When it acts on another get vector pi, you will get another eigenvalue mu multiplied by this get vectors pi. So now you take a inner product pi q cat psi, which can be written as, when q act on psi, you will get lambda psi. So you can take lambda outside. This is inner product between pi and psi. then you can bring this, you take this same inner product, that is pi q q operator q act on get vectors I here also. So now what I am going to do is I am going to bring this to the bra vector side. So if I bring q into the bra vector side, this is q dagger, which is equal to minus q, because you seen, because it is anti-Hermitian. Now when q act on pi, you will get the eigenvalue mu. Of course you have a negative sign here. So if you take out the mu, because mu is a number, but however mu is in bra vector side, so that is minus mu star. So minus mu star is equal to mu. In the part A we have seen that is here you can see minus mu star is equal to mu. We have seen in the part A. The eigenvalues are imaginary. So this is minus mu star will become mu. Then you compare this and this. This and this. Right hand side, you got same inner product. If you subtract this from this, you will get 0, because both are same. So equivalently, the left hand side, if you subtract the left hand side, this and this, you will get 0. That is lambda inner product of pi with psi minus mu inner product of pi with psi is equal to 0. This can be written as lambda minus mu pi inner product of pi with psi must be equal to 0. Here we have taken lambda is not equal to mu. Lambda is not equal to mu. Because we have the problem itself, it is asked plugging to distinct eigenvalues or orthogonal. So naturally, since lambda is not equal to mu, only possibility is this is 0. That is operator of different eigenvalue is orthogonal. We have proved that. So problem C also we have proved. Now we will move for problem T. Now part T is so that the commutator of two Hermitian operator is anti-Hermitian. How about commutator of two anti-Hermitian operator? First we will see the commutation relation for the Hermitian operator. This is the Hermitian operator. No. This is Hermitian operator. That is PQ whole dagger is when you taking the complex conjugate, then the order get reversed, you know very well. That is, this will become Q dagger, P dagger. So you know, since it is a Hermitian operator, Q dagger is equal to Q and P dagger is equal to P. So now what about its commutator? That is commutation of P with Q and dagger operator. So which can be written as PQ whole dagger minus QP whole dagger. So this is the commutation relation. Q whole dagger become Q dagger plus P dagger, because order get reversed when you are taking this dagger operation for both. So you will get PQ dagger is Q dagger P dagger, and QP dagger is equal to P dagger Q dagger, because order get reversed. Since it's a Hermitian, Q dagger is equal to Q and P dagger is equal to P, which is equal to QP minus PQ. So this is nothing but minus PQ, because PQ is equal to commutation with PQ is equal to PQ minus QP. You know it. But here you got QP minus PQ. So there is one negative sign. So the uh, commutator of Hermitian operator is anti-Hermitian. Naturally, this is anti-Hermitian. The best example is you take in quantum mechanics, you take position and momentum operator. Both are Hermitian operator. But however, the commutation of x with p is IH cross. The commutation of p with x is equal to minus IH cross. That means if you compare this and this, here you have minus IH cross. So the commutation of x with p is equal to minus commutation of p with x. This is a real example. Similarly, what about the anti-Hermitian operator? Anti-Hermitian operator means P dagger is equal to minus P, not P. Similarly, Q dagger is minus Q, not Q. So what about PQ dagger? So commutation of PQ, P with Q dagger, whole dagger. So first thing you will get like here, this order get reversed. You will get Q dagger, P dagger. Remember that this Q dagger is minus Q. Q dagger is minus Q and P dagger is minus P. This you have to keep it in your mind. So as such, you will get exactly what you have done here. Q dagger P minus P dagger Q dagger. Q dagger P dagger minus P dagger Q dagger. Now this will become minus Q and this will become minus P. So minus of minus will become plus. So naturally this will be QP. Similarly here also, this is minus P, P dagger is minus P, Q dagger is minus Q, minus of minus will become plus. So this will be minus PQ. So which is equal to minus P, commutation of P with Q. So exactly this is also anti-Hermitian. So we have proved up to D. We will move on to section E. Section E is so that any operator Q can be written as sum of Hermitian operator A and anti-Hermitian operator P. This you have to remember. This is anti-Hermitian operator. P is anti-Hermitian operator and A is Hermitian operator. Q can be written as given in the problem. You can write this as sum of two operator A and B. Here A is Hermitian, P is anti-Hermitian. Q is equal to A cat plus P cat. If you take dagger operation, then A dagger will become A itself. P dagger will become minus P because it's anti-Hermitian. Now you write the A cat. What is A cat? So if you subtract this, sorry, if you add Q and Q prime, what you will get? Q plus Q dagger. If you add these two, P will get cancelled. You will get 2A cat. So if you divide 1 over 2, you will get A cat. So A is a Hermitian operator, so no problem. Then A dagger is equal to same thing because A equal to A dagger. So A dagger also of Q dagger plus Q. So both are same. Uh, then what about to P, operator P? Operator P is equal to of Q minus Q dagger here. Q minus Q dagger. Then A will get cancelled. You will get 2p, because you are subtracting this from this, so you will get plus 2p. So naturally you will get uh, of 1 over 2 q cat minus q dagger cat. But here, unlike, because this is anti-Hermitian operator, you have to keep in your mind. So if you take anti-Hermitian operator, then this will be q dagger minus q, because p dagger is minus p. You multiply this by minus 1, then it will become q dagger minus q. So thank you very much for watching my video and supporting me continuously. Thank you very much.